Okay, 9,6 is kind of weird. There's 4 consecutive elements, they're unknowns, and then ionization energy, we have some numbers here without units. So the trick for this one is when they tell you consecutive, that means just like 4 in a row, sort of going across. So if you imagine a periodic table, it could be like 1, 2, 3, 4 in a row here, 1, 2, 3, 4 in a row here. So if you think about any row of 4 consecutive ones, in terms of ionization energy, you're going to expect it to be increasing going to the right. So we would expect from W to Z, the ionization energy would just increase. But then you'll notice that it does start to increase, so it goes from 148 to 21, but then it kind of goes down a little, and then it continues on its normal trend. So everything is good on this normal trend except for Y seems to be sort of a weird outlier. And then they do give us some possibilities, so you'll notice there's some options. So basically have all these possibilities ranging from Na, Mg, Al, Si, P, S. And then all the options here are kind of different combinations of these. So if we're looking for a set of 4, we're going to try to look for a combination, maybe like it could be these 4, could be like these 4 in a row. And we're going to try to look for reasons why maybe that third one would be off. So ionization energy is based on that first, that very outermost valence electron. So let's quickly just think about the electron configurations. So Na is 3s2, or sorry, 3s1, 3s2, and then Al, all the s's are going to be the same from here on out. So let's just look at P. So that's going to be 3p1. Okay, and then if we sort of draw it, so I should probably be drawing these boxes a little bigger for myself. And then this one's all full. So the first option that I'm given is ranging from Na to Si. Depending on if log kappa randomizes this, I'm not sure if it's going to be a slightly different order, but these are all just sort of different combinations you could do of 4 in a row. So from Na to Si, is there any reason where the third one would actually sort of deviate from this upward trend? And actually it's going to be yes, and it's going to be because of that. It's starting a new shell, and P is a little bit bigger, higher energy than S. So actually it is kind of easier to pluck out this P than one would expect. So this first combination is something that we're going to select. So I'm gonna, maybe I'll just mark it up there. Okay, the second combination is ranging from Al to S. So let's see, is there any reason for this third one to be easier than expected? And you can see, not really. We're just kind of adding an electron, adding in electrons, nothing weird is happening. So it doesn't look like this Al to S is going to be one combination that we can use. And then another combination would be P to Ar. So looking at this third one, is there any reason why this might be lower than expected? And it doesn't look like it. It looks like we're just filling in as normal. From here to here, not much of a difference, so it should just follow the trend. So it looks like we're not going to use that. From Mg to P, so is there any reason why this third one would be any different? From 3p1 to 3p2? Not really. It should just follow the normal trend we expect, so it doesn't look like we'll be using this one. And then the last combination possible is Si to Cl. So if we look at this third one, we kind of have everything lined up perfectly, each in its own box. And then as soon as you introduce this electron, now there's sort of repulsion within one box. So it actually is easier than expected to remove that electron because of the repulsions. So here there was no repulsions of things being squished in the same box, and then all of a sudden in this third one, now we're introducing some repulsions. So it looks like Si to Cl is another combination we can use. So the two combinations that we're going to use is the one from Na to Si, and then the one that went from Si to Cl. And depending on the letters that Lon Kappa gives you, for me, it was A and E, I believe, so I put in AE. I'm not sure if it's going to randomize it for you, so at the very least, at least you'll know how to get to here.